Of all the many components you can use in ArtMatic, perhaps one of the most important is the picture movie, which looks something like this. This component comes in different flavors, but substantially it lets you incorporate inside an ArtMatic system imagery that comes from outside ArtMatic, for example a still picture taken with a digital camera, or an existing video clip. Without the picture movie component, ArtMatic is a great synthesizer of astonishing abstract images, but with the picture movie component, ArtMatic becomes a powerful tool for transforming, more or less dramatically, existing images and videos. You can create weird and wonderful effects, and also simple but powerful effects that are difficult with high-end graphics and video post-production tools. There are many examples in the preset library, as you can see from the ArtMatic browser, and really you should explore these presets both to gain an insight about the applications of the picture movie input components, but also to use them as a starting point for the development of your own projects. Let's start building up a suitable structure from the Choose Structure drop-down menu. Let's choose the basic Scala, and now let's replace the tile in the middle with the picture movie one. By default, the picture used is the UNI software logo. Let's say I want to use this picture that I previously saved on disk. To incorporate the picture of the puppy in this ArtMatic structure, you need to make sure that the picture tile is selected. Then click on this little Choose Picture Movie drop-down tool. Click on one of the open slots and choose the picture file you want in this file selector. Here we go. Normally you will find that the imported picture is tiled into many clones of itself. You can control the tiling and the zoom using these two parameters of the picture component. Let's lock these two parameters so future randomization do not alter the zoom and tiling that I've just chosen. Now, the two input values of this component are the horizontal and vertical coordinates of a pixel within the picture or within a movie frame. The output value is, in this case, the brightness of the corresponding pixel, which is eventually mapped to a color from the active gradient. If the gradient is black and white, like in this case, the result is a grayscale version of the input source. But if the gradient is colored, the result will be a tinted version of the input source. Oh dear, poor puppy. Any spatial distortion introduced by the tree will effectively distort the image, which is a property exploited in many of the example files. In the case of this simple structure, I could replace the first tile, and instead of having this scale and offset component, I will have something that distorts the geometry, for example the multifractal displace. The extent of this displacement will be controlled by the parameter of this new component. The first one, for example, can be pushed back to 0 to achieve no distortion at all. Let me add this version to the keyframe stack. Then we can increase the value to achieve increasing degrees of distortion. And if I add this version as a keyframe and animate these two keyframes, I can see how the original puppy morphs into, well, something else. Let's start again from scratch, because I want to show you a different type of picture movie. I'll load up this simple structure RGB1 channel. This 3-output picture movie component can be used for RGB output and color processing. It returns the red, green, and blue values of the image's pixels. With this picture movie component, you can access the image's original colors and also perform color processing, since you can modulate the red, green, and blue picture channels independently. To demonstrate this, I will choose a color QuickTime movie instead of a still picture. we can control the color balance using the parameters of the last tile. First, let's reset them by clicking on the sliders while holding down the Control key on your computer keyboard. Now you can see that the 3 sliders control the red, green and blue color channels. This works well because this component performs linear transformations, but if you replace it with a non-linear one, expect the colors to go really wild. In this situation, ArtMatic offers a number of components that are specifically designed to control the color of the image, using the orthodox parameters of image editing you may be already familiar with from Photoshop or other similar applications. All sorts of distortions are still possible, as we saw earlier, so even with this simple structure featuring the RGB picture movie component, you can manipulate both the morphology and the color properties of your image. We covered just the basic features of 2 types of picture movie components. There is much more to it, and you are encouraged to check out the presets that come with ArtMatic. More information is also available in the Using Pictures and Movies chapter in the reference section of the user guide.